We're going to solve rational equations. Rational equations are just made up of rational expressions. And I'm going to write the stuff out the long way here. I suggest you do that in the beginning, but when you get the hang of it, you'll start to see how you can take shortcuts. So, to solve a rational expression, the first thing we're going to do is we're going to multiply through by the common denominator. And in this case, the common denominator would be 4x. So when I say common denominator, I'm including every single thing, not just in the two sides we're adding. So when I do that, I'm going to end up with this. So I multiply everything through by it. But now what's going to happen, if you notice, since we use the common denominator, the denominators in each piece are going to cancel something out. So we'll lose all the fractions. So in the first one we lose the x's, and I can do that, there's no plus signs. So 2 times 4 is 8, plus, this one I lose the 4, so 1 times x is x, and the last one I lose the x's, and that's 4. And now I get an equation that I can solve rather simply. Subtract 8 from both sides, and so x equals -4. The only thing we have to do that would be different from a regular equation is to look back at the denominators and see, is x allowed to be -4? Well, in this case, -4 will not produce a 0 in any denominator, and so we are fine. So that is the answer to the equation. This one we're going to be able to solve in two different ways, and I'll show you them both. First, I'll be consistent with the way I did before. Multiply through by the common denominator. So in this case it would be x times x minus 2. So let me do it the long way. And when I say long way, what I mean is eventually, without doing this, you'll be able to see what cancels right away and you won't write out all the pieces. So on the left side, the x's go away. And on the right side, I lose the x minus 2's. And now to solve this, I'm going to have to multiply everything out first. So on the left side, I get x squared minus 2x minus 3x plus 3. And on the right side, I get x squared minus 4x. Now this is a quadratic equation, at least what it looks like. So my first thought would be to bring everything over to one side. But if you notice, if I try to do that first and subtract the x squareds, they both go away with a little simplifying. Now if I just bring the 5x to the other side, I'll move up here to do it, we get 3 equals x. And again, I have to check the denominators, but neither denominator will have a problem with 3, so we're fine. Okay. There is another way to solve this one, though. So let me just pan over here to another copy of the equation. This is a ratio. So when I have things in a ratio, one fraction equal to another, I can cross multiply. And so I will get x minus 3 times x minus 2 equals x times x minus 4. And if you notice, that's the same exact thing as I had right over here. And so we'll end up solving the same exact way. Here's another one that would be a little trickier, only because I have to find the, I have to factor, excuse me, to find the common denominator. So the first piece will be factoring the denominator. And like in a lot of instances, the factors turn out nicely to be the same as the other two. So now the common denominator will be x plus 3, x minus 1. So let's multiply that through. Again, I'll do it the long way. Notice I didn't write the 1 in there. It wouldn't change anything if I did, but if you'd like to keep it there, that's fine. Alright, and now we can start canceling. So over here we lose the x plus 3's. So I'm left with x times x minus 1. Plus, over here we lose the x minus 1's. So I'm just left with the x plus 3. And over here we lose both. And so now if I multiply it out, I get x squared minus x plus x plus 3 equals 4. Now this is a quadratic that's not going away. So we're going to have to make it equal to 0. So if I bring the 4 to the other side, I get x squared, and these two, minus x plus x, cancel each other out. So x squared minus 1 equals 0. Alright, now if we remember correctly, if to factor this one out, that's how we'll solve the quadratic, assuming it's factorable, or we could use the quadratic formula. I'm going to bring this up here just so I have some room. This would factor as x minus 1, x plus 1 equals 0. And so here, x would equal 1, or x equals negative 1. So those would be the solutions, but I have to go back and check. And now we have trouble. Because right here, if x was 1, that would give me 1 minus 1, or 0. So that means 1 is not a solution. It came out as a solution, but it will not work. So we call this an extraneous solution. Sorry, I spelled that really bad. Or I wrote it really bad, I should say. An extraneous solution, so the only answer is x equals negative 1.